In this video, we are going to model a uPVC union from a tracing of the same so that we build it back to this shape that you are seeing here. A union actually is three parts. There are three bodies this side, and this is the end connector this side. Then we have the union nut, which is the middle part. Then we have what is called the body, which is on the other end. This one locks onto this one using square threads between this interface here. And both sides are threaded, and this side is 1 inch, and similarly to this side. In between the two, this face and this face, there is an O-ring which makes sure that there's no leakage when the union is in use. Welcome and thank you for joining us. And we want to sketch these three parts, the yellow, the blue, and the gray part, which are different components of the union. I'm going to speed up the video during the tracing process so that we can shorten the period. So there we have our sketch. So now we're going to scale the tracing. To begin, we need to find the distance between this point and this point so that we can use it for scaling the drawing. And with that, I shall go to Smart Dimension, then get these 2 points, find out the length, and that figure is 611.44. So I'll get out of that and escape so that we go back to our drawing. So we go to Scale, and Tools, we Scale, then we select the entities, remove that, we select all these entities. Everything is selected, and we want to scale about say this point. Okay, then now the scale factor is what we shall calculate, and this is 6. The actual distance between these 2 points is 67.5, so it is 67.5 divided by, this is 611.44. That is our scale factor, and we want to reduce that drawing by that much, and that is what I'll put here and accept. And there is our new scaled drawing, and I can check now the distance between this and this, and we see that it is 67.5. So we can check some relationship just to make sure that everything is fine. However, just to check also some other distances, this and this, that is close to what we have. This side, so I'll make this side equal to the other side, and we get it, the correct measurement is on this side. So this is going to give us 4.61. I'll go back to this side. Just accept. This side. Accept. Now these two lines are collinear. It's not a dimension. This and this, they are same. Accept. These two should be parallel. Then they're collinear. And basically with that I can let SOLIDWORKS do the calculation. Apart from, let me correct this angle here. On 50. Because that one is 30. Similarly, this and this. Make it 150. Let's measure this angle also. This is 120. These two lines are collinear. And I think with that, our diagram is looking good. Let's see if you can let SOLIDWORKS define the other Okay, still underdefined. So accept. After going through a cleaning process, I now have the diagram fully defined. And as you can see, I need to draw a line from here. This is a construction line. This line is horizontal and it's for construction. Accept. I'll check this distance here. That distance is not correct. I need to change it. We need to dimension the distance between this line and this one, and this distance is 12.5, which is half the diameter of the union. So we accept that, and on this side I'll add 0.55 to that dimension to give us 5.16. So essentially that brings this one and this one at the same level to this line. So with that, I exit the sketch. And we want to do a revolve boss. And our axis of revolution is this one. Then we accept. So this is our union. Within it, it has 3 bodies. If I put off these 2, you can see this is the outer nut. We shall later on put a square thread on that surface. Then we have the next body. This is the end connector, and it has a slot for an O-ring. This inner surface is going to be threaded. Then we have this other part. If I put this one off, so this is the one which presses the O-ring to ensure that there is no leakage in the interface between the front side and the back side of the union. So from here we shall proceed to make threads. There are 3 threads to be done: this face here and this side, then the threads on the 2 the union nut under the end connector surfaces, the interface where they are joining there, and that is going to be a square thread. this part we are making the threads, so I shall go to the thread wizard. Accept. Then the location is this one. And we want this location here. So that is our diameter, but I want yes, 4 millimeter, and we are using the square metric. If you don't have this one, follow my video on how to set up the square metric tab in SolidWorks. So here we are going to cut the thread. Okay, whenever you get this error, sometimes the solution is to chamfer this edge. So let me chamfer this edge. And let's adjust it to 1 small chamfer. We accept that. So let's now try the thread again. And the location is this one. Up to there. And that is the diameter, and that is the pitch. So we try to cut, and you can see it as accepted by just changing the entry conditions there. So those are the threads. So we accept this. Now we take the this one, and do the threads as well. So I'll activate it, then put off this one. Then now I'm left with it. So we shall also use a tab, but this time we are going to extrude the threads on that surface. So again, thread, so location is this point, and up to this point, and we want to extrude accept. Now that is our thread. Okay, I need to offset it on the last part there, inside. So we edit it. offset it inside. By say 0.5, so that it doesn't spill outside, or half the pitch, which is 2. Yes, let's accept that, and let's see how it looks like. So it doesn't spill over. Now this place here, we are going to modify that, and what we want to do here is to do a revolve cut there by first of all converting those entities. So I will convert the highlighted entities, then revolve that entity so that it gives us a curved finish. So let's do revolve boss. Then it is asking what is the axis. It is this one here. Then the degrees I just want something like 120. Yes, and you see with 120 it enters into the body of the nut. So let's accept that and see how it looks like. And you can see that the finishing of the edge there is nice compared to the way it was before. Similarly, I'll do a similar on this side. We need to convert entities. Then using that, I will do revolve boss. Then the axis of revolution is this one. Then the degrees is 120. And we accept that. Accept. And so you can see the nut is having a nice finish. So we accept this. So the nuts on the male and the female are now done. Now we look at the inner threads, which is this one here, and this is going to be a normal thread. So we take thread and also we shall do a tap. It is asking which location at this point up to this point, and the diameter is that one. So this is not a square this time, this is just a normal tap. And that one is close to that. To be precise, here's the thing, it has taken it. So let's see how, just before we accept everything. So accept. We need to modify that thread. To give it an offset. side. Okay, somewhere there, so you accept that. Yeah, so that is our thread entering nicely into the nut. So that one is done. We take this body, and we also do a similar thread. Okay, there we have it. Then we put a thread. The first location is here. Second location is there, and with the same definition. Let's make an offset. Accept. Yes. So now our three bodies have threads. So the other thing that we want to do is to emboss this surface and these three surfaces from here, this one, and this one. So from here, we are going to create some feature on this outer surface to provide grip when the union nut is being turned. So you can see the surface is very smooth. So what I want to do is to create a plane first, then develop the gripping body on that surface. So we go to plane, then I select this one here, then accept. So our plane is there. So let me make it normal and sketch on it. So it is here that we want to draw, and this body is just 1 millimeter. So I'll use a line, and from here go up 1 millimeter. Accept. Then go this way 2.5. Then come back to the circumference of that circle. There. And we get out of the line tool. So now we want to mirror these two lines, this one and this one. So mirror entities, and we want to mirror about this line here. Accept. Then we create this arc here. So I'll go to the three-point arc, then pick this point and this point, then drag our arc to match that line, and with that we have our body. So we accept that, and we want to extrude that sketch. So we want to extrude it to go to towards this edge here. Then we select extrude boss. Let's reverse the direction. Then we want to go to about 15, let me say 16, and the selected contours. Let's zoom in and pick that and that. Alright, yeah, then there we have the body. Okay, so we accept this, and you can see now, if I make it normal, let me turn it to the other side. So we want to do a circular pattern around the edge of the union nut, and with that we select it, then go to circular pattern, yes, I think you can use that alternate point. Then you can see the objects have been rotated, and we can accept that. And now you see the objects have been created that provide grip on the surface of the union nut. So we shall do the same on the end connector and the body of the union. So essentially that is the union. It was a sketch because we did not have the actual dimensions, but out of the sketch and tracing, we have been able to build it back to a model which can be fine-tuned and worked on further to improve the dimensions. Thank you for watching.